folks, Alex here. So I really want to dig a little bit into the realm of procedural macros in Rust. And as a kind of case study, I want to see like what we can do with the builder patterns, right? And the builder pattern is something that is pretty trivial, and you're probably like using it on a daily basis. Um, and usually it goes like this, right? So let's say I have a kind of struct human something, right? And like the whole premise here is that like instead of creating instances of that human, we'll create some kind of builder struct, builder type, to which we can delegate the building procedure of that human, right? So struct like builder and like this, but that of course is option string, like option u8, I guess, right? And allow the code. And the way it's supposed to work is that we just take this like human thingy, right? And like builder, and we just return a new kind of uninitialized builder, and then like impl, yeah, builder, almost the same. Yeah, like that's almost what I want, but I just want slightly different naming, I guess. Function with h, function build, and then this, and here we go, right? So tests, all that, and CFG test. So basically, like the way it works is that, again, instead of creating this human, right, we are calling this builder on it. We are getting this builder structure back, and then by using those with name and with age methods, we can actually like set individual fields of that builder, right? And then we can call build on it and just get the human back, basically. And why this is useful, it is a whole other story. But let's say this is useful. Usually it's useful because of the kind of data verification, sanitization, all that kind of stuff, defaults, all that can be encoded within those methods. But I digress. And yeah, let's go ahead and cargo test it. It works. It works, but there is a problem, right? So nothing really stops me from doing that, right? So I can call the build method on a non-initialized builder thingy, right? And as you can see, like the compiler has no problem with that. The compiler thinks that that's totally fine. But when I do cargo test on it again, of course it would fail because I'm trying to unwrap the non-variant of that option thingy, right? So these two are nonce, and I'm trying to like unwrap those, and that's not gonna happen. So no good. The other problem is that when I call with, let's say, age, when I do with again, it would suggest me to like reset this age or a name again, even though the age is being set already, right? Why would you do that? Of course, we understand why the IDE does it, right? Because it's just a set of methods on that builder thingy. But me as a software developer, right? Kind of my experience sucks here because I already set the age. Why would you do that? Like, what if what if there are a lot of fields like that, right? So I don't wanna like any kind of visual noise to it. So would have been great if somehow the builder just knew that that age already been set, right? So it's like, yeah, 30 with name, yeah, like Alice, build, and it's supposed to work. So let's go ahead and introduce the notion of the build step here, right? So it's like step. And what is this step anyways? So struct, I want to call it 0 and 1, right? And when we create the uninitialized builder, I want to say that this is like a 0, 0, 0 thingy, right? And step here is the phantom data, of course. And now, like, I actually get to decide what methods are available on which step, right? So, for example, for 0, 0, I want these two to be available, but not that one. right? I'm not supposed to build stuff on that. I'm not supposed to build the builder here because it's not been fully initialized, right? So with name, right? So the result of the with name should be builder 10, right? Because the name kind of, the zeros element of that human tuple. So I decided to like say that when you go from 0, 0, when you like set the name here, you get 1, 0 back, right? Of course, that would not work, out of the bat, and in order to make it work, you need to like transmute it from one type into another, and that transmute is totally fine because the underlying data is never being changed, right? So the only thing that is changed is the kind of tag that we associate with that type. But that tag is the compile time abstraction only, so no data associated to that tag. And the same thing here, right? So it should be like 0, 1, right? And should be transmute as well, like here transmute as well, right? And now let's go ahead and finish that bad boy up. So for 1, 0, we already did the name, so here should be 1, 1, right? And for 1, 0, for 0, 1, right? For 0, 1, that thing is already being called with name, and that should be 1, 1. And when we reach the 1, 1 state, right? The only thing that is left to call is this build method. Yeah, please, Copilot, just do this. Okay, fine. All right, and as you can probably tell, the tests are still fine, and we now have, some superpowers, right? So when I do like with name and like something like Alice, when I call with again, I only get to like witness this with H suggestion, not with H and with name, right? So with H, like 20 build, right? And I believe it's 20 now. Alice is supposed to be 20. Like, why she's 30? I don't know. And this build method is no longer available on that builder thingy, right? Specifically because, it's only available on the state 1, 1, but we are trying to invoke it on a state 0, 0, right? That's pretty neat. So if you ask me, like, that is pretty neat. The only problem with that implementation is that we effectively created kind of a set of all binary strings with the length n, where n is the number of fields on the original struct, right? And we all know that you get like 2 to the n unique strings, right? Unique binary strings. So basically, it will require us to like create 2 to the n impl blocks for that to work, which is no good, right? Thankfully, it's pretty easy to see like how we can optimize it even further, right? So for example, here builder 0, 0, and we get this with name thingy, right? And we get this with name here as well on 0, 1, which kind of suggests that we don't really care what is that, second tag is, right? We only care that the first one is 0, which means that we can actually eliminate that and actually say something like, let's say t here, right? T here, and so t here should give me t here, and here it should give me t there. And now it works again, right? So when you take the builder with first tag equal to t and second to 0, right? The only thing that you can do on that builder is to call with h on it, right? And the result of that is exactly the same t on the first position, and now it should be 1 on second. And exactly the same thing for that, right? And that like little optimization actually, tames the complexity from 2 to the n all the way down to n plus 1, actually, right? So here we need to like implement 3 of input blocks, right? Instead of 2 to the n, instead of like 4, right? And of course, like that difference becomes extremely apparent when n gets to, I don't know, 10 or something like that, right? So basically, like this is the implementation that we are looking for. So let's see if we can like encode that into a proc macro, right? So in order to start with proc macro, you actually need this, right? So it's like lib proc macro true, right? And cargo add proc macro to sin and quote, right? So template implementation of the derive macro using sin and quote crate, right? Let's see what it gives us. Anything, please? Okay. All right, so derive builder, huh? Right? Cool. And let's see how it works. So we will be needing to like create a macro derive builder, unused macro definition builder. Yeah, let's go ahead and create some kind of test polygon for us, like test rs, and here it's like, oh yeah, it's like test and it works or something, right? And structs pancakes, nah, human, like this, and derive builder. Cool. Proc macro derive and I think it should be pub as well. Yeah. And what is test? Hello macro. What's hello macro? Oh yeah. All right, so let's discuss that a little bit. So the way it's supposed to work is that here, when we like derive some kind of derive macro, right? When we like invoke it, what's actually happening is that we are actually like running some kind of Rust code on it, right? And yeah, so we are running some Rust code on it, but that Rust code actually takes the token stream as an input, and token stream is basically just a what it sounds like, right? It's just a stream of tokens, just huge kind of list of Rust's tokens, like lexical entities, right? And the way it's supposed to work, we should like somehow like compute the another like stream of tokens that should be appended to whatever we are deriving this macro for, right? So we should like produce some kind of Rust code that will be appended to that struct definition here, right? So let's see that. How we're gonna see that? So I'll do a cargo expand on that test, right? And here, let's do expand. How do I do that? So expand it. So on that expand, currently, as you can see, we only get in the human thingy itself, right? So we are deriving something, but we only get in human itself. And this is because why everything is so weird? Like why I'm getting, like why it should be that weird at all? Yeah, I don't know. VS Code is flaky sometimes. So like expanded or expanded, right? Yeah, let's go ahead and I don't know, like create some kind of other structure, maybe like hello, right? Let's expand it again, and you can see that now, alongside with this human thingy, I'm getting this hello thingy that I just created here. And this is like basically the way it works. So this proc macro thingy, right? Proc macro crate is a standard Rust library, right? Um, and the quote and scene are actually just userland crates created by some other guy that just help you to like implement your proc macros, right? So that's that. Right, so what's now? So basically I know that I will be needing to create a builder struct, right? So struct builder or like builder, right? But I don't know what are the fields here. So I'll do this like builder fields, right? And you know, I get to decide what are those fields, right? I also will be needing to create this to types, you know, struct 0 and struct 1, right? And when I have, yeah, and this builder thingy actually should be parameterized over this step as we saw. And here it's like step, phantom data step. And let's do impl block like for the struct name. Builder 0, builder init fields. So it like effectively that would be impl human, pop function builder, builder. It's a good question. What's that? So it's like this builder initial tags, right? And here, instead of that, I probably will do this, right? Which means that builder should be defaultable. So let's derive default here, which means that this should also derive default as well, right? And let's go ahead and try like struct name is this. Let builder field this is. Oh yeah, let's go ahead and make sure that we are working with a struct, right? So let, because like here, right, this AST thingy can actually be anything. So as you can see, it can either be a struct or enum or a union, but we only need the struct, right? So let's do, let's like scene, I guess. Data struct data AST data. Else like panic only works with structs, right? Let scene fields named fields. Yeah, exactly. So we only interested in the named fields, not any fields, right? Because like, what if our struct is something like struct hello string, something like that. So we don't want that. We want the actual struct that goes like this, right? Yeah, so basically we are extracting the data out of it. Let's data structure, I don't know, just make it easier. Builder fields. All right, so let's builder fields. And builder fields are, of course, just an optionized version of the original field set, right? And builder initial tags, so that's supposed to be just a bunch of zeros, actually. So let initial tags, not really. That should be like 0, right? Something like this. And builder final tags should be once. And we need builder final tags as well, because we know that when we go and use the builder on a final stage, right? So it's like builder, right? But that should be like builder final tags, right? We supposed to just have this public function build that takes self, returns a struct name, and does this, but not exactly, right? So should be like builder unwrap fields, something like this, and then let builder unwrap fields is basically just that. Yeah. All right. So this looks good to me. Let's see into what it actually unwraps into, right? So we are getting this human, right? Human. We have this two structs. We have a builder, right? Then we have a human that creates a new builder that has 0, 0 as an initial state. And we have this builder that can build when its state is 1, 1, right? And basically we need to implement everything that is in between, so, right? All right, so let's do this. Let's do this. I'll do this. So let's say we have something like builders or builder impulse or whatever, right? So what are these builder impulse? So builder impulse, let's see what it suggests, right? So we have this field, right? So that should be this, right? So it should be like impl builder current builder tags, right? Cool. So current builder tags, that should be like methods name, right? Field name, field type. Oh, this should be something like, what are we gonna call it? Next builder tags, right? Self field name equals to some field name, and this should be safe std mem transmute mem transmute self, sure. Cool. So now we get to decide what are these, right? And I would probably need that to be generic over a generic list or something like that. Let's see. It's like, oh, it's like generic list, something like that, right? All right, so we get to implement a lot of stuff here. So for example, let's do enumerate here as well. And I wanna index and field here, right? So let's see. Let method name. Method name is not that. It's something like quote format ident. I would say maybe like with field ident la la la, right? Then let field name is this, right? Field type is this. So generics list, interesting. So what are the generics, right? So here in our previous implementation, in order to make the builder work, we needed to like do something like impl, you know, like t, right? Like builder, something like t, you know, 0 or something, right? So we basically need to do that here as well. And generics list. So function generate generics list. So how many use size pause to skip, I guess, use size, and it should kind of return the implementation of the iterator of the item proc macro to token stream. How about that? And like to do, does that even make sense? Probably it does, right? So to how many? If the pause is pause to skip, iter no method iter for the range. That's weird. Okay. Index, we need index as well. Wow. Right? Sin index. Generic name is quote format ident this, and we'll just do generic name here, I guess. So basically, this function should produce a string of generics like T0, T1, T2, and all the way to the kind of Tn, right? So that's like generate generics list. And here it's like let generics is like generics generate generics list. Yeah. So generics list. And we'll be needing like current builder tags and next builder tags as well. Interesting. So I would expect it to be pretty much the same as that thing. So current builder tags, and let's see. Yeah, so it should be like 0 to how many, right? And let's see how it works. Yeah, like pause to skip, pause to set. Let's do this. So, and then this. So if the pause position of interest, if it's this, then we need to if pause of interest equals to equals to index. Yeah. We need we need 0 here. And otherwise we'll be needing let, yeah, like generic name this and like generic name basically, right? Will that work? Well, I think so. Basically here, when the pause of interest, when the like slot that we are working on right now is equal to a current iteration variable, right? We'll return 0, and otherwise we will return the generic thingy. So current builder tags, and the next builder tags, next builder tags is basically the same thing, but that should be 1. Let's see. Let current builder tags, the builder tags is basically this. And let next builder tags or whatever, yeah, like next builder tags is this, right? So looks good. Argo check. Tests expected 1 generic, and we have a lot. Let's see. So here, right? That one is probably okay. Builder impulse. And yeah, I think it doesn't like this. Oh no. Or is it? Yeah. It doesn't like this. Yeah, now it works. And let's see the expansion. Expand. So now we have this derived builder, blah, blah, blah. Right? Where is it? No, like expanded, right? So now what we see here is following. So we have this human, 0, 1, builder step, and then here, when we implement, yeah, like builder 1, 1 gives you human, which is what we want. We have this builder 0t1 with name that goes into 1t1, and we have this t00 that goes from that to t01, and that sets h, that sets name, right? So yeah, I mean, let's see if it works. So assert, yeah, like that, like Alice is human builder, Alice, age 42, sure. And like assert ick, Alice, or like Alice age is 42. And Alice's name is actually Alice. Let's go ahead and cargo test. Yeah, it works. Actually works. And let's see if our invariant holds, right? So like Alice, like let Alice is like human builder with, oh, I need to like rebuild the build script and proc macro. Okay, so with name Alice with age 42. And now I can call build, right? And that expects string, so to string, and assert eq Alice name is Alice, and assert eq Alice age is 42. Test. And if I did something like address, which is a string as well, right? Now I cannot build the Alice without the address being set, like with address Wonderland to string, right? Although, like, I feel like the IDE lags a little bit, but I know that that's not a problem. So I think, it will start lagging after the restart of the IDE. But I mean, looks like it works actually. So I think I'll call this W for now. We'll be needing to like clean up that code a little bit in future, and we'll be needing to like implement some of the kind of nicer stuff to it. Maybe something like I don't know, builder. I don't know, like defaults, maybe like 42 or something like that. I don't know, some kind of attribute macros would have been cool to have. Defaults, converters. It also would have been cool to support the option types, right? Because like now, if like this is an option of a string, right? We don't really want to create option string. So it would have been great if if our implementation understood that. But yeah, but I think, yeah, VS Code is laggy. But I think for now that's a W. So I'm gonna call it a W, I guess. And I'll see you on the next video. We'll proceed working on that. So see you guys next time.